Masa from Kyushu University. Thank you for interesting talk. And I have a question to Mei. And your research is very impressive, and you evaluated GitHub Copilot and retrieved the takeaway messages. And my question is that there are many LLM models, and how do we choose LLM models in the experiments to retrieve takeaway messages for developers who would like to use LLMs?
Thank you for the question. There are a lot of LLMs, but when it comes to actually LLMs that people are using when they are coding, there's fewer options, right? From what I can tell, Gemini is new. It wasn't there when we were doing our studies. There's cursor.ai. So only a couple of solutions are there. And it's not really what the model behind is doing that we are evaluating, but how users are interacting with these models, and what is it that they accept or what is it that they don't accept, and how are they modifying code once they accept. In all our examples, they have code that they get from Copilot, but they actually modify those examples, the code that they get, and they change it, right? So they make it their own. So yes, this is the generalizability problem that's there in other, it works on Java projects, does it work on C++ projects kind of thing. But I think there's far fewer production-ready coding assistants that are available.
Okay, I guess Hiro? Yeah.
Hi, this is Hiro. Thank you so much for a great presentation. I have a question to Foutse, and so I like the idea of adopting a chain of verification. So, but if I understand correctly, still the improvement can be limited by the knowledge of given large language model, right? So it means that still large language model could generate incorrect verifications as incorrect reasoning steps. So I'm curious that how still programmers may identify some incorrect verifications or incorrect reasoning steps. Maybe is it depending on the knowledge of how programmers are familiar with the target domain or programming environment, or if you have any thought about that?
Good. Very good question. So, of course, what I presented, if you had seen on the result on the slide, is not perfect, right? So those verification questions allow the models to at least self-check some specific aspect of the provider solution, potentially refining the solution before providing it to the author. Depending on the insights that we can have about a problem, we can design better verification questions. But the whole idea of the approach was that if we can use our domain knowledge, our knowledge of the problem, to somehow prompt and guide the models, we can get some improvements. But it's, of course, I agree, it's not a final solution. So it doesn't give you a totally error-free solution, but it can improve. And I think it can be combined with other approaches, right? That's also provide more richer context about the problems to further improve the solution of the model. But fundamentally, we need also to improve the model themselves instead of just a bit patching around the model as we currently do. So I think those two tracks of research needs to be evolving in parallel if we want to, at some point, end up with trustworthy models, for at least for the coding task. Yeah.
Hi, I am Babar from Huawei. I think my question is more for Professor Lei Ma. Thank you for the talk. That was an impressive talk. So I'm curious, how can we rely on the correctness of the Luna model? So do you have something to say about that? So there is this Luna model which validates the output of the AI models, and I think Luna model in itself is an AI model. How can we rely the output of that model?
So let me try to understand your question. So you are asking, we have a surrogate model, and how can we trust this surrogate model compared with the original one? Is that correct?
I think you talked about Luna model, right? L-U-N-A, Luna model. So in your talk.
What anomaly?
Luna, L-U-N-A.
Luna, yes,
yeah.
yes.
So I'm saying that how can we rely on the output of the Luna model itself? So which basically validates the output of other AI models.
Yeah, so that is, okay, so the large language model basically do the inference in a statistical way. And I think theoretically providing a rigorous formal verification on guaranteeing is theoretically very challenging. So what Luna is trying to do is also from the statistical point of view to understand, give some kind of a analysis, interpretation, and extract some kind of possible patterns that can provide the reasoning understanding for that behavior. And based on that, we can actually do some kind of analysis and provide some kind of useful feedback for the developers. Again, it's not a very like a formal verification absolute guarantee, but it's more focusing on provide some useful feedback that can be leveraged by the developers as a feedback to understand the challenges and problems inside the model and how to improve it. So it's more like in that kind of soft way instead of a rigorous hard way.
Okay. Would there be any false positives for the model itself, for the Luna model?
Sorry, can you?
Would there be any false positives? Like would they say any things that are incorrect, like the model itself, Luna model?
Yeah. Thank you for the question. And I think for many of the tools for either AI model analysis or large language model analysis, there will be definitely false positives things. What we are trying to do, how to minimize these kind of false positive possibilities and try to highlight more on the useful information that can be providing to the developer. The challenge here is that looking at the black box is very, very challenging. But when we have a way to reason about it, it's a direction to think about, and we can improve it gradually through iterations. That's actually what I mentioned. It's not a one-stop solution. It's more like starting a possible direction for further adventure.
Thank you.
Yeah, thank you.
So I have a question for the other authors here, the other presenters here.
Okay.
Given that in all our work, we're finding that these tools are helpful, but they still have, like Foutse, your work says that there's so many bugs, so many problems that are coming out that are appearing in the code generated by these tools, and there's false positives, there's ethical considerations, there's so many different things. Do we think that these tools are going to ever go in the autopilot mode, that they will just generate code, that they will, are we expecting that future at all?
Well, I'm optimistic. I think they will get better and better, right? So I don't think coding task that's so diverse as we may like to think. I think at some point, to some extent, it's quite repetitive, which means at least for an important part of the task, we'll be able to build models that, even if they are not intelligent in the sense that they can reason, because of, as we were saying, scale seems to be something very powerful. So because of scaling laws and because of all this effort that we're putting in guiding and fine-tuning the model, I think we'll be getting models that's good at doing certain coding tasks, I believe. But I also believe that there will probably always be a subset of problems that will be harder to crack, at least in a medium horizon, which will require potentially developer interacting with the models in a more clever ways to solve those problems. That's why I think all this research is interesting. First, to improve the model, but also to better understand how to work with the models, right? To kind of provide more trustworthy solutions. Yeah. I don't know my colleagues want to react on it.
Yeah, I also agree with Foutse. I think the trust sometimes is not only a technical issue, but also it's actually an interactive issue. So even maybe ideally we have an AGI that's super strong and it's actually can provide an ideal solution for every possible cases. But if this is a black box, we don't have much interaction without gradually building this trust, then still technically it's really better, but we still don't have enough trust on it. Yeah. So I think in the practical applications for nowadays, it's more like a thing about to balance the cost and also the usefulness of the tool. Like if, just like the false positive cases, so if we have too many false positive, even if it's sometimes useful, it's very difficult to be used in practice. Yeah.
I think there were two questions somewhere here.
Hello, I'm Qinghua Lu from Cyro Data System Australia. I have a question for Fuyuki. So thank you for the interesting talk. The first, actually two questions. The first question is, could you share more insights on the foundation model-based system evaluation, especially the use case specific, the customizable evaluation? Then my second question is for the software engineering community, we talk a lot about AI testing, AI evaluation, system evaluation. But in maybe machine learning community, they talk about model validation, model testing, then policy people talk about like risk assessment, impact assessment. So do you think having a standardized terminology or further clarification would be helpful? Thanks.
Thank you for the question. So for the past was okay. Each side of the evaluate custom AI this. So what I heard from my industry partners, basically it's very difficult because the outputs or input to the LLM and outputs are text are fully formatted. So there are a lot of possibilities, and we cannot predict all of the possibilities beforehand. So that's the source of the difficulties. And one thing, another thing is, I already mentioned the cost of building the custom evaluation test data set. There are so many benchmarks, and we cannot know which one is better to choose for custom evaluation of the AI. So, but how to say, yeah, that's typical comment. Maybe I'm forgetting something, but yes, that's a typical comment for the evaluating custom AI. And sorry, what the second question was? Sorry, standard. Sorry, standard.
Terminology.
Terminology using AI and SE are slightly different. How to?
Okay, sorry. Yes, the terminology between the AI people and the software engineering people different. How to do? Yeah, we both have history and both want to have power. So there are ISO standards from the software people. They want to make ISO standards from the AI people. So we are connected. So if we start from scratch, we can have the unified standard terminology, I hope. But I don't think either stops using your own terminology. So somehow we need to connect and share or translate, I guess.
Hello, Gustavo from Huawei. I have a question about the sustainability of these models for software engineering tasks. So we know from Foutse's study that lots of people are using Copilot, right? So this code is already on GitHub, many projects, right? And we know from Mei's studies that this code looks kind of different from what humans would write. So if we keep training these models on more and more synthetic data, so couldn't we reach a point where these models are perhaps dumber or they just cannot help us as effectively anymore? Thank you. And this is to whoever wants to answer that.
Yeah, I mean, this is, I think, a bit a popular concern more and more because we kind of hitting a limit of new tokens to feed the models. So they are starting consuming more synthetic tokens. And there have been some early studies suggesting that there is a risk of some mode collapse, so the performance will just go down if we keep doing this. which means we will have to find ways to still provide more diverse and fresh tokens to feed the models. So that's a general concern. It's not just a software engineering problem. I mean, all the machine learning community is also facing that issues. It may require us rethinking the architecture of the model, the way we actually do build train those models. And it's a valid concern, right? So that's something. That's also why I think traceability is very important. Like currently, people are using these tools. There's a lot of GitHub repository already containing Copilot codes, but we don't have a clear traceability, right? Which makes the situation even worse. So I think if we start right now, early on, adopting these good practices of making sure that everything is tagged, and then we can trace whatever is a human-driven written code and whatever is generated, then probably we can at least delay this issue of model collapse, which is pending to us. I think it's a problem.
So yeah, I agree, right? Like there's already, some of the AI folks are already worried about model collapse, not just from a code perspective, but also generally these models that are consuming things on the internet, which overwhelmingly now is generated by these tools. And some of the AI folks are talking about the next generation of models are not just going to be bigger models trained on more data that in a similar way, but rather we're going to reach AGI not just by being bigger, but through different ways. This is a great first step, but it's not just a linear step forward to get it. I don't, like, we should ask the AI people what they're going to do to change the way that they build these models and what data they consume.
Thank you.
I would like to add a little bit on Foutse and Mei's comments. I think here it's a really complicated problem because the speed of generating new content by these Gen AI is much faster than, than what we can produce by humans. And if the quality of generating continuously steering into the weird direction, that can actually pollute what we might originally want the model to do. And I think the biggest challenge is how to provide the ecosystem that can guarantee that the data, for example, in the pool can be somehow of good quality, and we have some automated measurement technique that can help us to do this. And furthermore, for all the contributors, for example, worldwide, we need some kind of a reward mechanism other than everyone can provide something, but eventually no one actually gets real benefit. Only the few big techs actually are the final winners. So I think the way how we democratize and how we reconstruct this kind of ecosystem is also very important. Otherwise, it's easily go to
I just agree with Lei. So the question is whether we rely on the free use of internet data, or if near future should we have a job that creates professional training data, and people creating professional training data have proper rewards. So I expect that scheme is a kind of beautiful or sustainable.
Yeah, my worry, sorry, just to conclude, like my worry as a MSR guy is like I cannot just go to GitHub and clearly see what code is human-made and what code is,
So we need traceability, right? We need to really enforce. But I think there may be some hope with the regulation that is coming, right? If you look at the EU regulation, there is enforcement of making sure that everything that is, at least for image generations and videos and the others, everything that is synthetic, be explicitly watermarked as synthetics, right? So I think as this regulation will be rolling out, there may be hope that it will be enforced to some extent, and then we may be starting seeing a clear distinction between these different artifacts, and that may help. Yeah.
There's any more questions? Okay. Take this one more, then.
Okay. Hi, I'm a PhD student at Kyushu University. I'm Yuta Ishimoto, and I'm working on the SE for AI topic, and I'm especially impressed by white box approach introduced by Dr. Ma and QA for AI guideline introduced by Professor Ishikawa. And yeah, we can, by this approach, we can identify the issues related to the fairness or robustness on LLMs. But the next step naturally considered is how to fix the issues or problems occurred in the LLMs. So I'd like to happy to hear your opinions about how to fix the misbehavior or incorrect behavior by our own LLMs.
Yeah, that is a really hard question. So I'm not sure how much you have solved for the traditional neural networks for the supervised learning context. So machine learning people has really a lot of effort on the knowledge editing or updating the obsolete knowledge. So that could be the one hit, but I'm not really sure it works generally for robustness or fairness or whatever. So I guess there should be a lot of techniques or software engineering techniques and machine learning community who is improving the fairness of each quality characteristics. I believe we will have some solutions. I personally like knowledge editing and manipulating a specific part of the neural network personally, but I believe there will be a lot of techniques. My point is a little more about the balancing different quality characteristics. If you want to avoid hallucination, okay, your GPT may not answer to anything. So I'm also interested in the future techniques to how to balance the trade-off.
Yeah, maybe I add a little bit to Professor Ishikawa. So I think the reason that can cause the eventual model behavior incorrectness can come from so many stages in the whole foundation model or large language model life cycle. And I think we don't have a really nice, deep understanding on where and in which stage how these, for example, behaviors are produced and introduced. So in that sense, some kind of meta-level analysis understanding can automate a massive scale of experimentation evaluation to understand on each step how these kind of errors are introduced in each step, or incorrect capability introduced in each step could be first step help us to understand why it happens. And based on each reason that how it happens, then we can have a better and clear way to move forward. For example, it's a data quantity issue, then we do more on data side. If it's a models issue, we can do more on the model side. Or it's like a deployment issue, then we should optimize more on the AI stack level, or even the chip architecture design. So I think it's a quite complicated issue here.
Yeah. I totally agree. We need a deep understanding of how the model works, and I think it was Dennis' talk yesterday who was advocating for more type of experimentation to get a better grasp of the intention of the model and why the model behave the way they behave. And I think it's only through this type of experimentation that we will be able to have the right diagnostics, and then we can think about designing mechanism to actually improve the model durably in a durable world, instead of just hard aligning them as we're currently doing with different techniques like reinforcement learning from human feedback and so on, which is more kind of ad hoc mechanism to just force the behavior in the model instead of solving the root cause of the problems. Yeah, I think a lot of interesting, exciting research problem to solve.
Okay, I guess let's close the session. Let's thank all the speakers.
Thank you.